Hi, Assalamualaikum and good day everyone. So today we will continue our lesson with chapter 5, Numerical Integration. As we all know, integration is a process of measuring the area under a function fx, which is plotted on a graph. Mathematically, integration can be written as integral of fx with respect to the variable x from a to b, and this a is the lower limit and b is the upper limit. So this expression here represents the area of this shaded region. Before this, we have learned on how to find the integral of a function by using analytical way, such that by using a few formulas, by using integration by part, and also by using integration by substitution. When trying to evaluate definite integrals analytically, sometimes it is very difficult or even impossible to determine a function's entire derivative. When analytical methods fail, we can use a numerical approach to approximate a definite integral. Under this course, we will only consider two methods to approximate definite integral: trapezoidal rule and also Simpson rule. The first method to approximate the integral of a function is by using trapezoidal rule. Trapezoidal rule is equivalent to approximate the area of the trapezoid under the straight line connecting FA and also FB. So we are now finding the area of this trapezoid to approximate the integral of the function fx. As we all know, the area of trapezoid is given by the formula 1/2 times with the total length of the parallel side and times with the height of the trapezoid. From this illustration here, this is the B1 and this is the B2, and this is the height of this trapezoid. So now the area of this trapezoid is 1/2 times with the B1 is actually the F of A, and B2 is the F of B, and the height, the h of this trapezoid is the length from A to B, that is B minus with A. So to compute the integral of fx from A to B, the formula is just the formula to compute the area of a trapezoid. FA plus FB over 2 times with B minus with A. This formula is called single trapezoidal rule since we only have one trapezoid. The problem with this formula is that you will encounter a very large error. That is, you might get a value that is very far from the true value of the definite integral. To improve the accuracy of this rule, we can divide the integration interval AB into a number of segments. The improvement method is called the composite trapezoidal rule. Suppose we want to find the integral of fx from interval a to b. Instead of having just one trapezoid, we can draw multiple trapezoids. For example, now I have 4 trapezoids. So my n is equal to 4. Now we are going to divide the interval AB into 4 equal parts. So to do that, we can find the length of interval A to B, which is B minus A, and we can divide it with n equal parts. So as for now, my n is equal to 4. So in my illustration here, I have 4 trapezoids, and the length of each trapezoid is B minus A over 4. Okay. So for now, I will name the first point here as x0, x1, the second point is x1, x2, x3, and this B here is x4. Next, we are going to construct our trapezoid. So this is my first trapezoid, second trapezoid, third trapezoid, and the fourth trapezoid. So this is my T1, T2, T3, T4. To find the area and the graph fx, we can just find the total area of these 4 trapezoids. And we know that the area of trapezoid is given by the formula half times b1 plus b2, where b1 and b2 is the length of the parallel side, and times its h. H is the height of the trapezoid, and in our case, this h is equal to b minus a over 4, which is the length of each equal part. So the area of the first trapezoid is 1 over 2 times it. The b1 is the f of x naught plus with b2 is f of xy, and times with h. So our h is b minus a over 4. So for the second trapezoid, the area is half times with f of xy plus f of x2 times with b minus a over 4. And for the third trapezoid, half times f of x2 plus f of x3 times with b minus a over 4. And for the fourth trapezoid, the area is half times with f of x3 plus with f of x4 times with b minus a over 4. So now to compute this integral, the integration of fx from a to b, we just find the total area for these 4 trapezoids. T1 plus area of T2 plus area of T3 plus the area of T4. As you can see from these 4 expressions, for each of the expression we have common factor 1 over 2 and also b minus a over 4. So I can factor out the common factor b minus a over 4, and also we have 1 over 2, so So I can put 2 in front of these 4. Okay. And then f of x naught plus f of x1 plus f of x1 plus of x2 plus f of x2 plus f of x3 plus f of x3 and plus with f of x4. And then I also can simplify further by adding the common term, by adding the like term. F of x0 plus f of x1 plus f of x1, so 2 f of x1 plus 2 f of x2 plus 2 f of x3 plus with f of x4. So this is basically the formula to find the integral of fx from a to b, given that we are dividing the interval into 4 equal parts. As you can see from this formula, the first term, the coefficient is 1, the second term, the third term, and the fourth term, the coefficients are 2, and the last term, the coefficient is 1. What will happen is you want to find the integral of a function from a to b, and now you want to divide into n equal parts. So the formula is given by b minus a divided by this 2 here is fixed number 2, and this 4 now is equal to n, since we are now dividing to n equal parts, so 2n, and times with the first term, the coefficient of the first term always 1, so f of x0 plus, and the coefficient of the middle terms always 2, so plus 2 f of x1 plus 2 f of x2 until plus 2 f of x n minus 1. And the last term, the coefficient always 1. So the last term is f of x n. So this is the general formula to find the integral of fx from interval a to b, given that we are now dividing the interval ab into n equal parts. So that's all for this segment. So for the next video, I will show you a few examples of trapezoidal rule.